You ready?
Yeah.
Right. This is our project, Absolute Value Summative by Derek Nuna and Herman Poon. Scenario 1. Suppose a train is at station 1 as shown. It leaves that station and travels towards station 2 at a constant rate of 45 miles per hour. There are no passengers waiting at the second station, so the train continues on toward its final destination. 225 miles away from station 2, let X represent time and Y represent the distance the train is from station 2. The equation would be Fx equals 45 times the absolute value of X minus 4. This is our graph for scenario 1. The y-axis is the distance from station 2 in miles, and the x-axis is the time, which is in hours.
The original domain and context of the situation would be x is greater than 0 or equal to 0. The real world meaning of domain, since x represents time, it's impossible to go back in time, so it can only be 0 or greater. The reasonable range and context of the situation is y is equal to or greater than 0. The real world meaning of range is how far close the train is to station 2. Applicable applicable intercepts in context of the situation 0, 180, and 4, 0. Real world real world meaning of applicable intercepts is 080 represents where station 1 is and how far it is from station 2, and 40 represents where station 2 is.
The maximum slash minimum value for domain in this situation is less than or equal to 0. The real world meaning of maximum slash minimum is the maximum slash minimum shows how close you possibly are to station 2. The vertex as a coordinate pair is 4, 0. The real world meaning of the vertex is that 4, 0 is where station 2 is located. The x-axis of symmetry is x equals 4. The real world meaning of the axis of symmetry is how it shows the speed of the train is linear.
In scenario 2, how will the key attributes of the equation be affected if the speed of the train changes from 45 miles per hour to 90 miles per hour? Describe any changes that occurs to the real world meaning in the situation. This is our graph of scenario 2. The x-axis represents time in hours, and the y-axis represents the distance from station 2 in miles.
Domain is greater than or equal to 0. The range is greater than or equal to 0 also. And the intercepts are 0, 180, and 2, 0.
The maximum slash minimum is greater than or equal to 0. The vertex is 2, 0, and the axis of symmetry is x equals 2.
In scenario 2, the time would be 1 and 2/9 of hours, or 2 and 7/9 of hours when the train is 70 miles away from station 2. The equation would be 90 times the absolute value of x minus 2 equals 70. First, you would split the two equations, positive and negative. 90 times the absolute value of x minus 2 equals 70, and 90 times the absolute value of x minus 2 equals negative 70. Second, divide both sides by 45 times the absolute value of x minus 4 equals 7/9, and the absolute value of x minus 4 equals negative 7/9. Third, add 4 to both sides. X equals 2 and 7/9, and x equals 1 and 2/9.
In scenario 1, the time would be 5 and 5/9 hours, or 2 and 4/9 hours when the train is 70 miles away from station 2. The equation would be 45 times the absolute value of x minus 4 equals 70. First, you will split the two equations into a positive and negative, which would be 45 times the absolute value of x minus 4 equals 70, and 45 times the absolute value of x minus 4 equals negative 70. Then you would divide both sides by 45 and you'll get the absolute value of x minus 4 equals 14 ninths, and the absolute value of x minus 4 equals negative 14th ninths. Then lastly, you'll add 4 to both sides and you'll get x equals 5 and 5 ninths and x equals 2 and 4 ninths.
Let's go. Finally.
That works, yeah.
All right. Let me take out this recording. And I'll send it to you, man. We'll see. We'll both see if it's